next little bit, we are on to laws of new. It will be new. It will be new to most. And it can get a little bit complicated. Okay, we've got a few laws that we've got to remember, and we've got to know how to use them and apply them, solve equations with them, and so on. Okay, so bear with this. It can get a little bit complicated, but with practice, we should be all right. Before we get on to that, the first thing I just want to have a quick look at is just look at the graphs of logarithms. Now, the same as with any other function, you can always find the graph just by plugging numbers in. So you can just put numbers straight into your function and you'll get a graph out. So in this case, we're looking at log base 2 of x, and all we're going to do is just plug a load of numbers in and we'll see what we come out with. Okay, so if we start with 0.25, okay, actually what I want you to do now, can you pause the video for me? Get those filled in, get a little graph plotted so you can see what it looks like, just so you can practice plugging these into your calculator, see what we've got. So pause, fill them in and get them plotted for me. Okay guys, right, let's have a look then. So we're doing log base 2, so 0.25 we should come out at -2. 0.5 we should come out at 1, we should come out at 0. 2 gives us 1. 4 gives us 2. And 8 will give us 3. Now, we'll spend a bit of time looking at logs and you'll see why these come out as they do later on, okay? If we just plot our graph quickly, so 0.25 minus 2 somewhere in there, 0.5 minus 1, 1, 0, 2, 1, 4, 2, and 8, which is going to be all the way along here at 3. And if we join them up, what you can see is we get a curve like that. Okay. Now, important facts to remember: we are going to have our asymptote down here at x equals 0. Okay. And as we get bigger and bigger powers of x, this is going to flatten off. It's going to keep increasing, okay, but it is going to flatten off. So the rate of increase is going to get less and less and less and less, but it is always going to keep increasing. The other thing that's worth noting is we never have anything this side of the graph. We cannot log a negative number, okay? Now that becomes really important when it gets to solving our logarithmic equations, okay? So that's really important. As long as we have a rough idea of what they look like, guys, that's absolutely fine. We can always plug numbers in if we need to. Right, on to the laws of logs. Now, all I want you to do, first of all, is just pause the video and write these down, okay? I will then talk through them and we'll have a little look at where they come in place, but it's definitely worth having these written down. These are what you've got to remember. So, first one we got. You've got log base a of x plus log base a of y equals log base a of x, y. So basically, when we add logs together, they must have the same base. That's really, really important. So in this case, the base is a. Okay, but obviously the base may be a number. As long as we've got the same base, when we add them together, we can multiply. Okay, so log base a of x plus log base a of y equals log base a of xy. But they have to have the same base. Similar with the next one. Again, make sure they've got the same base. Okay, but log base a of x minus log base a of y is going to be log base a of x over y. Work in quite a similar way to powers and how your index laws worked back in Key Stage 3, okay, when you first learnt about them. The fact that you add and multiply is a couple, as is divide and subtract. And the only other one that we need to remember is log base a of x to the k. Now it's really important that the power is just on what we are logging, gives us k log a of x. Okay, that's really, really important, is that the power is just on what we are logging, not on the whole thing. Okay, please make sure you write these down. A couple of special cases that are really, really helpful. Log base a of a. So if your base matches your same number, you get 1 out. And if you log 1 of any base, you get 0. Okay. Obviously, providing you're not doing log base 1. Okay. The other one that is really helpful, if you are doing log of 1 over something, we can rearrange that using our powers to give us x to the minus 1. Okay, so just a simple index law, which we can then rearrange to give us minus. That is a special case of that law there. Okay, because we can get something to the power of minus 1, and we can track that out. Make sure you've got this copied down, because when I go through some of the simplifying log stuff, you'll have something to refer back to each time. Okay, right. Let's just have a look at a few. So, first of all we're going to be looking at doing is we're going to be looking at simplifying them. So, writing them as a single log. So, from your laws, all you need to be able to do is make sure you recognise what law you can apply to it and how we're going to do it. Okay. Now, all we're trying to do is write our answer as log base something of a number. Okay, so we get rid of any adds, any subtracts, anything like that. So this first one, first of all, make sure you've got the same base. Okay, now in this case we have most of the time in the work you will do, you will have the same base. Okay, so we've got the same base. So I'm adding. Now we should remember that when we're adding with logs, the couple is with multiplying. So this will become log base 3 of 6 times 7, which will give us log base 3 of 42. Now I find it really, really helpful when I'm handwriting these to always put what I am logging in brackets. Okay, mainly it's to do with handwriting. Okay, because it can get really, really confusing. Otherwise, you may end up thinking you've got log of 342, for example. Okay, it's completely up to you. It is something that I've found helps me when I'm working these out to make sure I do understand what my base is and what the number is that I'm logging. Okay. Next one. Again, we've got the same base, so I'm quite happy to move on to the next step. Same base, so this time I'm subtracting. The couple that goes with subtracting is divide. So this is going to become log base 2 of 15 over 3, which is going to become log base 2 of 5. Okay. Right, third one. First of all, we've got the same base, which is brilliant. Now, what you need to know about this is you can't add or subtract logs while you've got a coefficient in front of it. Okay, while you've got a coefficient there, you cannot do it. So the first thing we've got to do is get rid of these coefficients in front. Now, one of our log laws was how we could eliminate a power from the number we're logging by bringing it in front. So what we're going to do is we're going to do the reverse, basically. So 2 log base 5 of 3 can become log base 5 of 3 squared. The 2 becomes the power inside. The same with the next one. Can become log base 5 of 2 cubed. So I can write them out. I'm just going to change where I've put this simply so that it matches a bit better. So we have log base 5 of 9 plus log base 5 of 8. Now we're back in the same position as we were with the first one. We've got the same base. My addition couple is to multiply them together. So I'll have log base 5 of 9 times 8. So we'll have log base 5 of 72. Okay. Right, last one, little bit trickier. But again, I've got the same base, so I'm quite happy I can move on and simplify these. Okay. First one, nothing I can do with the first one, so that's going to stay as log base 10 of 3. Right, this one, I'm going to get rid of the 4 first. So this becomes log base 10 of a half to the power of 4. Okay. Right, half to the power of 4, so this will still be log base 10 of 3, will become log base 10 of 1 over 16. Okay, right, one of the last ones we looked at, I can rewrite 1 over 16 as 16 to the minus 1. So this will become log 10 of 3 minus log 10 of 16 to the power of minus 1. And then the 16 to the power of minus 1, I can take the minus 1 out. So I can have log base 10 of 3. Minus and a minus will give me a plus. Log base 10 of 16. Okay, this one is by far the most complicated one. Just move up a little bit. Okay, so now I'm in the position that I have been before. I've got the same base, I've just got logs, so I can add these together. Adding them means multiplying what's in the middle. So I will finish with log base 10 of 16 times 3, which is 48. Okay, that last one by far the most complicated, okay, but it's one to watch out for, because it's the law that was up here, okay, with the reciprocating one. This one at the very bottom, okay, this one just here, okay. And it's really important we notice that, because that can get us out of a lot of problems with these. Okay, right. The other type of simplifying will be ones where you've got different variables. Okay, now this wants you to write it in terms of log ax, log ay, and log az. Okay, so at the moment these will multiply. And basically, we're going to have to go backwards. Okay, from what we did have. So backwards from what we were doing in this first part. Okay. So when I'm multiplying, I know that the couple pair with multiplying was adding. So I can rewrite this first part as log base a of x squared plus log base a of y plus log base a of z cubed. Okay. Now we just want it in terms of log x, log y, and log z. So I need to get rid of the powers. So to get rid of the powers, as long as it's only the part I'm logging, which is the power, which it is in this case, I can bring the power in front. So I'll have 2 log a x plus a log a y plus a 3 log a of z. Okay, so it's literally going in reverse, guys, to what you're doing in that first part. Okay, same with the next time. This time we're dividing. So the couplet goes with dividing and subtracting. So the first thing to do is to separate that. So I'll have log a of x minus log a of y cubed. This one. Again, just need to simplify my y cubed out. So I'll have log a of x minus 3 log a of y. Okay. Just quickly run through the last couple. So log a of x root y over z. Again, let's separate all the parts out. So I'll have log base a of x plus log base a of root y. Actually, we'll simplify that straight away. Root y we should know is y to the power of a half. Minus, because then it was a divide, log base a of z. Now the only part I need to simplify is the half, so I can bring that one in front. So I'll have log base a of x plus log base a, plus half even, log base a of y minus a log base a of z. Okay. Very last one. I wanted to include this one because there is an extra layer of simplifying in this. Okay, So when we simplify, so if I separate first, and I've got to divide so I know it's a subtract, I get to this point. I can take the power of 4 out, so I'll have log base a of x minus 4 log base a of a. Now, one of these special cases we had was where if I'm logging the same thing as I've got a base of, that gave me 1. Okay, now that's really, really important to watch out for. Okay, because especially when we come to solving these later on, that can be a big, big part of what we're looking at. Okay, that can be really, really helpful. So we know that log base a of a must equal 1. So therefore, this whole part here is going to be 4 times 1, which is going to be 4. So that can finish off as log base a of x minus 4. So it's that extra layer of simplifying, noticing that we're logging a number that's got the same base. Okay, so I can simplify that step further. This is more complicated, guys, and it does. You have to be really neat with what your base is. You're using bases that you can see that it is subscript, okay, underneath. So it is really, really clear that it's a base, because in your working, if you've got lines and lines of work, you need to be able to pick out quite quickly what the base is you're working with. Okay, please be careful. Please take your time. Right, I want you to pause the video, and if you can pause the video now for me. Those 7 that are now, and then we will have a quick look through them. Okay, if you need to rewind and have a look, then that's absolutely fine. Okay, guys, right, let's run through these ones nice and quickly. So, log base 2 of 6 plus log base 2 of 4, adding our couple with adding is multiplying, so that would be log base 2 of 6 times 4, so that should be log base 2 of 24. Next one, same base, so I'm happy. I'm subtracting, so the couple with subtract is divide, so I'll do log base 6 of 20 divided by 4 to give me 5. This one, again, I cannot add or subtract with logs if I've got a coefficient. So my first thing always needs to be to get rid of that. So I'll have log base 5 of 3 cubed plus log base 5 of 2. So that will become log base 5 of 27 plus log base 5 of 2. So we end up with log base 5 of 54. Final one, little bit more complicated. The first part's absolutely fine, so I can leave that as log base 10 of 2. Put my 3 back inside because I can't have a coefficient in front, so that becomes log base 10 of 1 of a third cubed. So I'll have log base 10 of 2 minus log base 10 of 1 over 27 can be rewritten as log base 10 of 2 plus log base 10 of 27, because 1 over 27 will be 27 to the power of minus 1. Bring the minus in front to make that a plus instead. So this will become log base 10 of 54. Now the couple just having to go backwards. Multiplying links with our adding, so this will become log of x squared plus log of y. Bring the squared in front, so I'll have 2 log x plus log y. Now, I will mention this now, sometimes they won't include bases, okay? Now, last lesson, we did briefly look at this. By convention, if it is not stated, we use that the base is 10 unless you are told otherwise. Okay, you may be told otherwise in some exam questions because they do like to use log base e as just log instead, but at the moment, if it doesn't tell you, you don't need to worry about a base. Okay, it should tell you in the question, and sometimes it makes it a bit easier not having a base because it's just a bit easier to write and work out with. Okay, this second one, separate them, so we'll have log x minus log y plus log z. Okay, and but that needs to be in brackets because that is on the bottom. So be really careful with this. I wonder how many of you got caught out by this one. Okay, because you are subtracting that whole thing. So that means that this should actually be log x minus log of y minus log of z. Okay, because you've got the power, you can't ignore your laws with brackets. Okay, last one, definitely a bit harder. So we'll have log of root x, cube root x even, minus, just stick that in brackets, log of cube root yz. Okay. Now if we want this as logs of x, logs of y, and logs of z, so we'll have log x of a third, so I've just changed that to a power. Then these are being multiplied together, so this is going to be log of yz to the power of a third. Okay, then we can have a third log x, so take the third out, minus a third, don't need that bracket in there, minus a third log of yz. Now I can separate my yz's. A third log x minus a third log y plus minus a third log y plus a third log z. Minus a third minus a third log z. Now that last one was a lot more complicated. Guys, that we get a toping, 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 guys, that we get a bit manipulating these around. Okay. Right. Just a couple of things for you to on this, guys, okay? On this, guys, okay? On this, guys, okay? So a couple of things that log a of b plus c is not the same as doing log a of b plus log a of c. Okay, there is no method to simplify if you're adding together. You just add them together. Okay, you only have that when they are multiplied. Okay, so that's really important. Okay, that does not work. The same way that if you are cubing log 2x, that is not 3 log base 2 of x, okay? Because that will be log base 2 of x times log base 2 of x times log base 2 of x. A very different thing. So 2 things for you to be really careful of that I do not want to see people making mistakes with, okay? Really common ones we need to be really careful with. The last thing I want you to go through, I do apologise, it is quite a lot to get your heads around, guys. This is the only thing I'm going to ask you to do today. Okay, it's only one exercise that I need you to do. It is quite difficult. It is quite long. Okay, the last little bit is to solve with logarithms. Okay, now, in order to solve with it, obviously you need to have a logarithm that's all on its own. okay, for you to be able to do it. And we should know, okay, from last lesson that the inverse of logging is to do the power. Okay, so if we look at, actually we'll start on the right hand side because this one's probably slightly easier. Okay, so we'll start over here. So we've got log base 10 of 3x minus 2. Okay, let's just rewrite that here actually. Log base 10 of 3x minus 2 equals 2. Now what I need to get rid of, in order to find x, I need to get rid of my log base 10. Now this is where I will always use balancing equations, and that's why last lesson, that's the method I would always choose to use, because when it comes to solving it becomes much easier. Because the opposite of doing a log base 10 is to do 10 to the power of. So what I'll do is I'll do 10 to the power of each side. That 10 to the power of cancels out that log. So I'm just left with 3x minus 2. 10 to the power of 2 will give me 100. Be really careful, guys. This means 10 to the power of 2, not 2 to the power of 10. Okay, you are raising whatever number you had here. Okay, and that's going to become the power. Okay, so be really careful with that. Simple equation to solve now. 3x will be 102. So x will have to be 34. Okay, but it's getting used to that 10 to the power bit is the opposite. Okay. Next one. In order to solve them, we've got to have it as one single logarithm. So we've got to simplify that left-hand side first. Okay. So I'll have log base 10 of 4. Obviously the bases now are really important. I can't add while I've got a coefficient in front of a log. So we'll move that inside. So we'll have log base 10 of x squared equals 2. Okay. When I'm adding with logs, providing I've got the same base, which I have here at 10, okay, I can combine these together. The couple with adding logs like this is to multiply the two parts together. So I'll have log base 10 of 4 times x to give me 4x squared equals 2. Right, now I've got a single logarithm. The opposite to doing log base 10 is to do 10 to the power of both sides. Again, that 10 to the power cancels out the log 10. So I'm just left with 4x squared equals 10 to the power of 2 to give me 100. X squared will equal 25. So x can be plus or minus 5. However, as we should have noticed from the first part, when we remember going back to the graph, we cannot log a negative. Okay. Therefore, because in here we would end up doing log base 10 of minus 5, because that can't happen, only answer is x equals 5. Okay. Again, really, really important part. Right. I do want you to try the 3 that are on your screen now. Okay, the first one shouldn't be too bad, very similar to the one I've just been through. The next 2, potentially slightly more difficult. Pause them, have a go at them, then we will go through them. Okay, there are more examples in your textbook. Okay, if not, please get in contact with me and we can go through some more. So have a pause, go through these for me, and then we will have a look at them afterwards. Okay guys, so 3 on here. We'll start in the top left, very similar to the one I just went through with you. Okay, almost identical in fact. Okay, so we've got to have a single log first. So that can stay as log base 10 of 4. This needs to become log base 10 of x squared. Oh, didn't want it to do that. And that will then give us 4. Adding 2 logs like this means I can multiply the parts together. So I'll have log base 10 of 4x squared equals 4. The opposite of doing log 10 is to do 10 to the power of either side. So I cancel out my log base 10. 4x squared is 10 to the power of 4. Okay, which will give me 10,000. X squared will equal 2,500. So x will equal plus or minus 50, but obviously we can't have a negative, so x will only equal 50. Okay, so that first one, very similar to the one that I went through as an example. Next two are slightly harder. Okay, so let's just move over this way a little bit. So, log base 9 of x minus 5 plus log base 9 of x plus 3 equals 1. Right. So, we know when we are adding two logs like this, as long as they've got the same base which they have, which is a base of 9, okay, we can multiply them. So this will become log base 9 of x minus 5, x plus 3 equals 1. So we can expand our brackets out. So I'll have log base 9 of x squared minus 2x minus 15 equals 1. Right, you've got to be careful because you raise to the power of whatever your base is. So this one has got to be 9 to the power rather than 10 because it's a log base 9. So the opposite of log base 9 is 9 to the power. So I will end up with x squared minus 2x minus 15 equals 9. And we're left with a quadratic to solve. So we move our 9 across. X squared minus 2x minus 24 equals 0. And we can then solve. So we'll have x minus 6, x plus 4. So I can have x equals 6 or x equals minus 4. Just got to check to see what we can have. X equals 6 will work because we'll both have positive, because we'll have positives for both. X equals minus 4 will not because we can't log a negative. So we'll ignore that answer. So we will just have x equaling 6. Okay, so that's a case of a bit of extra algebra involved, but the rules are all the same. Okay, all the same laws. Right, last one. Take it from an exam question. It is an old spec exam question. Okay, so given that 2 log base 2 of x plus 15 minus log base 2 of x equals 6, show that x squared minus 34x plus 225 equals 0. So, we know to solve, we're looking at solving this, aren't we? So, I need to get it so it's an individual log first. So, first thing I'm going to do is get rid of the coefficient in front, because I know I can't simplify while I've got a coefficient in front. So, this will end up becoming log base 2 of x plus 15 squared minus log base 2 of x equals 6. I can expand that bracket out. Log base 2 of x squared plus 30x plus 225 minus log base 2 of x equals 6. Right, I know when this works that I've got to divide. Okay, because when I'm subtracting I'm going to divide. So I'll have log base 2 of x squared plus 30x plus 225 all over x equals 6. So we'll just have a little bit of a simplify. So we'll end up with log base 2, 30 plus 30 plus 30 plus 30 plus 225 over x equals 6. So I now got it as one fraction. Okay. Now what I could have actually done, thinking about it, let's just go back a step. let's just leave it as that fraction instead. That might be a bit easier, so we'll just ignore that bit. So we're now at a point where we've got it written as a single logarithm. Okay, so I now need to get rid of my log base 2. Inverse it, so it's going to be 2 to the power of each side, because that will then counteract the log base 2. So I'm going to have x squared plus 30x plus 225 all over x is going to be the same as 2 to the power of 6, which is going to be 64. Okay, because remember, it's 2 to the power of whatever number it is. So I want to be left with x squared plus 30x plus 225 equals 64x. Manoeuvre that to the other side. X squared minus 34x plus 225 equals 0. Got there eventually. Hence or otherwise solve. Well, we've got our quadratic, we've just got to solve it. Looking at this, the best idea is going to be to use the quadratic formula. So we'll plug that into our quadratic formula. Again, if you're going to use the solver on your calculators, that's fine, but you have at least got to show it's substituting in first. So we have 34 plus or minus the square root of minus 34 squared minus 4 times 1 times 225 all over 2. You can put that through your calculators, and your two answers you should get out will be minus 34, and we should get x equals 25 and x can equal 9. Just double check that both of them will work. Well, if we go back to the question, both of them would work and give us a positive answer, so I'm happy with both of those as final answers. That last one, guys, is a little bit complicated. That's where I hope you will be by the end of the lesson. Okay. Now you may need to go back through the video, make some more notes, rewatch some explanations, and that is absolutely fine. Once you've done that, what I want you to do is go back onto Show My Homework and look at what questions I want you to do from exercise 14E. It is all I'm going to ask you to do today is that one exercise, okay? You've just got to practice these, guys. It seems really difficult at the moment, okay? It is quite complex. There's a lot of bits to remember. You've just got to practice it. If you have any problems, please email me.